How far can you throw a ball? Or more precisely, what is the best angle to throw a ball? Although this might seem like a simple problem, it's a great entry point into learning how to use calculus to solve problems. I want to give you an intuition for how to solve a problem like this, while also going through the math step by step, and give you an intuition for how to solve problems like this in all of physics. So, let's start by picturing it. We pick up a ball and throw it, and then throw it at some other angle, maybe almost straight up. And obviously we can see the ball doesn't travel as far this time. We can also try a really low angle. This also doesn't seem to fly as far. So we can already see just from this that the solution we want is in between these two angles. The furthest range you can get is somewhere between these two. You might already be able to guess what it is. So let's measure it. We throw the ball and vary the angle we throw it. Here we have all the possible different arcs we could get by varying the angle. Decreasing the angle, we can see that the range keeps increasing until some point where it flips around and starts to decrease. Taking a closer look, we can see how increasing by a further 5 degrees manages to still increase the range. Up until some point where we reach a maximum value. This point where the sign flips from positive to negative is where our maximum range is. Now, equipped with some visual intuition, let's head into the math of this problem. So, we'll start with Newton's equations and retrace our steps from earlier in the video. We threw the ball and watched it fly through the air and land at some point. Now, we have an expression for how far the ball goes. We know the initial velocity we threw the ball with, but we don't know how long it takes for the ball to fly through the air and then land at some unknown place. So we need an equation for that. Writing this in terms of delta t, we get now we have another problem. This equation depends on the final velocity of the ball, which we don't know. What we do know is the initial velocity of the ball. And luckily we know that the y velocity that the ball has when it lands is the same as the velocity it has when it leaves your hand. So now that we have an expression for t, we can substitute it in. In this case, the acceleration in the x direction is actually 0, since we aren't taking into account air resistance or friction during the flight of the ball. Using some trigonometry, we get that the x and y velocities are v cos theta and v sin theta. Substituting this into the equation, we get the following expression. And rearranging, we can see there's actually a trig identity in here. We can replace that with sine 2 theta, and we get our expression for the range. Now we know the range of a ball thrown at any angle. So which angle gives us the most range? Well, remember from the beginning of the video, we varied theta, and when the rate at which delta x is changing flips from positive to negative, we know we have the maximum range. All we have to do is write this down mathematically. When the rate of change of delta x with respect to theta goes from positive to negative, or in other words, 0, we have the max range. So, taking the derivative with respect to x, we know the derivative is 0 at some point, So we can insert this and instead solve for the angle. We can read the equation as, what is the angle when the range is the maximum? Here, it doesn't matter what the whole first term is. We can divide by it on both sides and it disappears. Now, doing the inverse of the cos function to both sides. And solving for theta, we get the final answer. The best angle to throw a ball is 45 degrees. Maybe you guessed the answer from the beginning, but the point is being able to solve this by yourself. You can get a real sense of achievement and build up confidence in your abilities by solving random problems like this. The real trick is getting past those walls where you get stuck and you don't know what to do. So just remember, always picture the situation first. However you want, it doesn't have to be a graph. Read each equation like it's a sentence. Maths is a language, and there's a natural way to read it. Try and rephrase the question in a simpler or a more specific way. And see what happens at the extremes of a problem. Doing this can often shed light on the problem in general. And see what happens if you vary a variable. Does the output get bigger or smaller? All these different things will help you get past those points in a problem where you just get stuck. They can help you explore the problem and gain a lot of interest for it once you get these barriers out of the way.